So the last thing we need to talk about in this first section of part 3 is solving inequalities using algebra. So we're going to kind of step away from graphing the parabolas. Instead, we're going to still look at a quadratic equation, but we're going to solve it now and figure out what would be like the restrictions on your variable. And we're going to do this using some of those other techniques that we've talked about this chapter, like factoring and that kind of stuff. So in order to help us do that, you're going to want to set your, instead of doing an inequality, set it equal to 0. So replace it with an equal sign. Think of it as just a regular equation to get started. Then you're going to want to factor it. That's finding those zeros or finding like your solutions to the problem. And then we'll talk about them on the number line. And then we'll go over like how do you decide where on the number line are good solutions. So for this first one, I have x squared minus 10x plus 18 less than or equal to negative 3. So what I'm going to do first is move negative 3 over because I want to set this equal to 0. So I'm going to add 3 to the 18. So it says x squared minus 10x, 18 plus 3 is going to be 21. And then I'm just going to go ahead and say equals 0. I'll deal with the inequality sign a little bit later. So because this one just says x squared, there's no number in front of the x squared except for that 1. I'm going to try to factor this. So I'm going to go ahead and just drop x's into each set of parentheses. Now, can you guys think of two numbers that would multiply to 21 and add to a negative 10? And they both have to be negative. So I'm going to do x minus 7, x minus 3. That way if I multiply them, I get positive 21. If I add them, I get that negative 10. So then if I set these equal to 0, so if you do x minus 7 equals 0, x minus 3 equals 0, you get x equals 7 and x equals 3. Okay, these are what are known as your boundary points. So what they want us to do from here, because we're dealing with an inequality, if we come back up, remember it started as less than or equal to. It didn't actually start as equal. We need to figure out how do we graph this on the number line and which type of numbers are we working with for our solution set. Because if I were to graph 3 and 7 on a regular number line, if I put 3 here, that means 7 is off to the right. Okay, I'm not going to fill in a whole bunch of other stuff. I'm just going to plot those two solutions on there. But what I need to figure out is, do my solutions sit in between 3 and 7? Or do they go opposite directions? Are they to the left of 3 and to the right of 7? Because it could be one or the other because of our inequality sign. So in order to figure out where we shade, because right now, I've got filled in circles at 3 and 7, because those are solution sets, and they're filled in because we have an equal sign in our inequality. But I need to know, where do I shade? Do I shade in between the circles, or does the shading go in opposite directions? So to do that, we have to do some testing. So you want to pick numbers that aren't 3 and 7. So you want to pick a number that's less than 3, a number that's in between 3 and 7, and a number that's greater than 7. So you want to kind of pick some points that aren't sitting as your solutions right now. And what you're going to do is take that number that you're picking and put it in for x in the equation that they give you and see if you get a true or false statement, because that'll tell you where you're supposed to shade. So for example, a number less than 3, an easy one would be 0. Okay, so if I put x equals 0, and I plug that in to this equation here, x squared minus 10x plus 18. I want to see if that would be less than or equal to negative 3. So if I plug in 0, it'd be 0 squared minus 10 times 0 plus 18. Checking to see if it's less than or equal to negative 3. I'm basically seeing, is it true or false? Well, 0 squared and negative 10 minus 0 are all gone because it's just a 0 there. So I'm left with 18 less than or equal to negative 3. True or false? false. So remember yesterday when we were graphing quadratics, I said that if you were picking a point and plugging it in and it didn't work, that meant that you don't shade there. So I do not want to include 0 because it doesn't work. That also means that any other numbers that would be smaller than 3, like 2 and 1 and 0 and -1 and -2, also aren't going to work. So I don't want to shade on this side of the graph. So I'm going to go ahead and X that out. Now if we pick a number in the middle, like x equals, let's just do 5, because that's in between 3 and 7. Then I put 5 in for all those x's. So I do 5 squared minus 10 times 5 plus 18 less than or equal to -3. So we'd have 25 minus 50 plus 18. I end up with -7. Is -7 less than -3? Yes, -7 would be smaller. It's farther to the left on the number line. So this would be true. That means that I want to be able to shade in between these two numbers. Okay, now just to kind of finish up this, to really make sure that I did it right, I could pick one more number. This time it'd be bigger than 7, so like 10. And it doesn't have to be 10. It could be 8, could be 9, could be 11, could be 12, could be whatever you want. It just has to be bigger than 7. Then I plug all those numbers in. So 10 squared minus 10 times 10 plus 18 less than or equal to -3. I get 100 minus 100, which is 0, plus 18. 18 less than or equal to -3. We had that earlier and we said that that was false, so it's still false. It hasn't changed since I did that first operation with it. So I also don't want that side of the graph. So do you have to test all those numbers every single time? Not necessarily. If it's going to shade in between the numbers, it's probably not going to go past those two numbers. It's going to stay contained inside the circles. Now, if the middle one, if this one, x equals 5, had been false instead of true, and the other ones that I had as false switched, then you would be shading so that they'd go opposite of each other. So the middle between 3 and 7 would stay clear. You wouldn't be shading in there. Let's do another one together. So for this next one, I have -2x squared plus 3x plus 7 less than 2. I'm going to start by setting it equal to 0, so I got to move that 2 over. So I'm going to subtract it. So now it says -2x squared plus 3x plus 5. And I'm going to go ahead and say equals 0. Again, we'll come back to that inequality sign later. Okay, now to solve this one, you can kind of decide what you want to do. Because there's a number sitting in front of x squared, you don't necessarily have to factor this one, because if you do, you'll have to do the longer factoring. You could try a quadratic formula if you wanted to. You can really do whichever method you would rather do. Let's say you guys want to use quadratic formula. So we would do opposite of b, which would be -3, plus or minus b squared, which would be 3 squared, minus 4. A is a -2, c is a 5. And this is all over 2 times a, 2 times -2. Simplifying, I have -3 plus or minus 9 plus 40 all over -4. So then I have -3 plus or minus the square root of 49 over -4. The square root of 49 is 7, so I have -3 plus or minus 7 all over -4. So I have to do the two operations here. So -3 plus 7. What would be -3 plus 7? 4. And what's 4 divided by negative 4? Negative 1. So one of your answers is negative 1. What's negative 3 minus 7? Negative 10. So I have negative 10 over negative 4. It's going to become positive. So think of 10 over 4. If we take a 2 out of 10 and out of 4, we have 5 over 2. So these are my two answers. And if you factored instead, you would get those same two answers. So I'm going to go ahead and put these on my number line. Again, your number lines don't have to be anything fancy. You can just put negative 1 and then 5 over 2. I don't need to see the stuff in the middle. Now, for this one, because the inequality sign has no equal sign, it's just less than up here in the equation, that means you're going to have open circles around those solutions because there's no equal sign. So this is kind of like the equivalent of, is your line solid or dashed? Okay, if it has an equal sign, you fill those circles in because it includes those two numbers. If it doesn't have that equal sign, it doesn't include those numbers. So now let's just pick a number. Let's go ahead and pick one in the middle. An easy number in between negative 1 and then 5 over 2 would be the same thing as 2.5 is 0. So let's test if x equals 0. Let's see if we get a true or false answer here. So if I put zeros in for all of my x's, I would have negative 2 times 0 squared plus 3 times 0 plus 7. We're testing to see if that's less than 2. What am I going to get on the left side? Seven less than 2, right? True or false? False. That means I don't want to include 0. So I don't want to include the space in between those two numbers. So my shading is actually going to go in opposite directions for this one. Now you could go and you could check other numbers, like you could check negative 2, you could check a 3. That would be greater and less than those two solution points. They should get you true answers if you do that. But I think that if you guys are able to just test one and see if it's true or false, it should help you see where you should shade. So in this case, 0 didn't work. 0's in between those two numbers up there. So I don't want to include it. So I don't shade in the middle. They go opposite of each other. Okay, so why don't you guys try number 3. You should be able to factor this one easily if that's what you're going to choose to do. So the first thing I would have done is moved your 11 by subtracting it so that you can set it equal to 0. So it says x squared minus x minus 6 equals 0. How would you factor this one? Good. Minus 3 plus 2. That way when you multiply those, you get your negative 6, but when you add, you get a negative 1. So the two solutions would be 3 and negative 2. So we put those on our number line up here. Negative 2 is going to be on the left side. 3 is going to be on the right side. Are you guys going to have open or closed circles? Good. Open, because there's no equal sign with this inequality. So, again, I would maybe test a point that's easy, like 0 if you can. I would always use 0 because 0 is the easiest number to operate with when you're multiplying. So if I test x equals 0, I'm going to do 0 squared minus 0 plus 5 less than 11. So you get 5 is less than 11. True or false? True. So that means that 0 is a good number, so we want to include it. So I want to shade in between my two numbers here, because that's where 0 would be. 0 would be in between negative 2 and 3 if you think about it on the number line. Then again, if you wanted to really justify and make sure that those other ones don't work, you could test those points. But I'm also okay if you want to pick like a 0. And usually 0 works. The only time you don't want to use 0 is if it's one of your solutions. Then pick a different number. But make it, again, make it easy on yourself. Pick a small number. You don't have to pick like 20. You could do whatever you wanted. Okay?